So if dive deep binary search, they use the real practical numbers. It will tell a different story per se. I I don't necessarily know what's the difference between these binary search from the previous video. I just believe they may have tweaked the code a little, but when it comes down to the big picture view, it's still very same. So and I just feel it's the same. Yeah. So first, dive deep into these numbers, the items that they use. So we're gonna do a play. We're gonna play it out, right? So the first item is 1 and 100. So the mid value are instance for the mid, which is basically the low high divided by 2. So straight away we get a 50, and then the next is that 100 and the 50, and this one obviously is the mid. And so it asks the value, is it towards where, left or right? It's towards left. So my high shift to 49, and then now our new mid will then become this number 1 and 49. I think it's around like maybe say 25. Yeah, so 25, and then we ask again, is it left, right? It become left. So our new high then become 24, and now our new mid update again. It will then become yeah, it become 12. So it's what, left or right? It's left again. So my high I mean it shift to 11, and this 11 and our mid then will have to actually become I think become 6. So it asks left, right, it become right. So now we shift the low instead. So instead of the 1, we shift it to above the mid, which is then 7th. And then our mid value then become so it asks left or right. It obviously go right again. So my 7 remove again, and then become the final value, which is 10. And now my mid will then become 10, and then it will actually say that okay, 10 is actually the right value, and it actually return to the system per se. So it's a bunch of this looping system between the low, high, and the mid, reshifting of all these mechanism, which I call A, and then operation A, and this one operation B. So operation A is looping everything between the low, high, and the mid, and finally go operation B, which return the result to the system as a whole. So that's the big picture idea of binary search. You may argue that why use binary search? The counter argument is that you can actually use brute force. that you actually go you got a value of like 1 to 100, and you slowly one by one find until the value for the 10. But the thing about this is that it requires a worst case scenario, big O n time complexity. But when you actually compare to binary search, it's because it's of how many 2 can I actually divide, how many 2 can I actually divide by, right? Like how many of those for the n value, because we are constantly cutting all the values by half if you were to see. So it's like saying that there's like a list of values and I want to find this value. Usually I start with the midway point and it tell me go toward the left, and I straight away cut off these right values, then start with from center, and then is it right or left, is it right, then I cut off all these value, and then I start to search towards the left and finally find the value. So if you see the constant movement of each move, it actually reduces the values by half, reduced by half. That's why it's n, which is the in array, divided by how many times that I do need to actually cut by half to actually find my value. So in another words, this is actually talking about log base 2 n, where how many times do I need to divide the n divide by 2 to actually find my value. So it's then further simplified to become without the base 2, we usually write as log n. So that will be our big O operation to be, as compared to n, where n is like a full list of like numbers that the in array you are using. But log n is pretty much constantly cut by half, and pretty much almost half as compared to n, which is much more efficient. So that's why we argue that we use the binary search as opposed to the brute force way. In terms of the condition after, after condition is just simply to do a lot with, which we actually dive a lot deep about, which is that we constantly manipulate both the L, H, and the M, keep on reshifting until the result value. I think that's the main condition that we play with. Not so much about the condition, before condition, because I think before conditions usually during LeetCode question, then it come out, then you need to find a way for you to insert your binary search and tweak according to the rules of the LeetCode question. So that's when before condition will actually come into play, and you see how you can actually make use of the property of binary search, which is the LHM, to actually fit into your criteria for the rule book in the LeetCode question. So yeah, there you have it. Everything comes to an end.